Okay, short video about overloaded strings extension in Haskell. If you start to use Haskell, you know that strings in Haskell is actually a list of char, and the char represents the Unicode character. And that's okay, but there is some problems with this encoding of the string, because list is a Haskell list is a linked list, and to store this string we need some extra memory to the pointers, to store the pointers to the next node and so on, and that's why it's not very effective to store the strings inside the list of chars as a list of chars. And also, if you represent strings in such a way, it is not very effective to operate with them. And to improve this, Haskell has a time and space efficient implementation of Unicode text. This implementation is defined in data text module. Okay. Also, Haskell has a module data.byteString, which implements a time and space efficient byte vectors. It uses packed word 8 arrays. We can encode a sequence of binary data with this module data types, or also we can encode ASCII strings, because ASCII chars can be encoded with 1 byte, and we can represent such type of ASCII strings with a byte string. But we can't represent with a byte string any char of Unicode table, because in this case the chars which encoded with many bytes will be truncated to 1 byte. Okay. To represent all Unicode strings, you need to use the data.text module. Okay, I provide here this overloaded strings extension, and now let's import the qualified these modules. This will be the text module, SD, and also we import qualified data byte string as byte string, the S. And also let's import some module which represents some additional function to working with the strings. And we interested in some type class in this module. Okay. Actually, this module data.string has a type class which called IsString. This type class allows to us to represent some type of values as a string literals. So usually if we provide some string literal, it has this type. Actually, this is a list of chars and this is a string type. But if we, for some type, provide the instance of the IsString type class, we will use this overloaded strings extension, we will have ability to represent this type on which we implement this type class, to represent its values as strings. So actually we need to implement only one method of this type class. This type class has only one function from string, which convert a string literal or a list of chars or a string type into the type class type. Okay, so what I mean? Actually, I mean that, okay, let's look at some function which represented in a text module. It called, I think, it called pack. So let's reload and look at this type. So actually, this pack function, it's take a not very effective representation of the string as a linked list and convert it to a effective packed representation of text. So we can provide some string here, and as a result we have this effective text type. Okay. And now we have this pack function, and also we have this type class inside this module, and the text type has the instance of this IsString type class, and actually it is implemented with this. So this from string function is actually defined as pack function. So it takes strings and put it to the text. And having this, we can just represent some text values as the string literals. What I mean? Okay. So this is how I defined a simple string. But now I can also define the text type, text string. And here I will give the type for this value. I want to say that this is a text type, and as you can see, there is no errors here because I use this overloaded strings model, and text type has the instance of the IsString type class, which actually pack the string into the text value. And that's how Haskell can know that it needs to transfer this string into the text type. So actually I represent my text value as a string literal using these things. And also the byte string type can be represented in such a way as a string literal. Okay, we can write byte string and define it as a byte string, byte string. It's like this, I think. And this will be compiled. As you can see, we can now look at our simple string, at our text string, and the text string has type text, and the byte string. So actually we can write here that it ASCII byte string. Okay. They can see that it has byte string type, and also it has the show instance, and we can print it on our console. And as you may guess, we can use in such a way we can use string literal representation of any type if they provide this type class instance. What I mean, for example, if I have some type, for example, some type foo, which can be divided to nullary constructor A and B, and some other constructor of type with type string, and let's derive show for it. I can provide the instance of IsString Typeclass for my foo type, and I just need to provide one function from string. And I can say that if I have string A, this means that I want to construct my foo type with A constructor. But if I have string B, I want to construct my type with B constructor. And otherwise, if I have some other string, I want to construct it with a other constructor and provide this string here. After this, now I can, for example, use string literal here and provide my type value of foo type. And you can see this is awk because Haskell knows how to transfer string literal into my type. Okay, you can see here we constructed our type value with this string literal actually. Of course, then we represent our strings as a text, as a unicode. We can manipulate somehow these strings. For example, we can just with simple strings, then they can concatenate them. For example, we can also concatenate texts. So we have this function append, I think. The append, if you look at its type signature, you can see that it's append to text. So we can append our TS and TS, and we have these appended strings. Okay. And of course, we can encode our Unicode text into some encodings. For example, we can encode it into UTF-8. Let's import our encoding module, and now we can, let's reload, we can encode UTF-8. So we need to provide some text as an argument, and you can see we have this byte string which encoded and in UTF-8 format. And this means that after they do this encoding, we can send this byte string somehow somewhere into the file, into the socket, and so on. Hey guys, thanks for watching. Push like, push subscribe, write comments, and see you in the next video.